And for this question, we need to set up a differential equation and then solve it. So according to Newton's law of cooling, the rate of change of the temperature. Okay, so first of all, I'm going to use a capital T for the temperature. And I'm going to use a lowercase t for time. Oh, I guess it told me to do that right there. Okay, so capital T for temperature, small t for time. And it says that the rate of change of the temperature, so that's saying the derivative of the temperature with respect to time, is proportional, so that means that it's a constant, times the difference between the temperature and the ambient temperature. So that means it's the difference between the temperature and the ambient temperature, which in this problem, the room is 50 degrees. So that is the difference. Now that we've set up the differential equation, we can solve it. And this is separable, so we can put all of the capital T information on the left side. So divide both sides by t minus 50. And then also multiply both sides by dt. And so on this side, dt's are going to cancel, or d lowercase t's will cancel. There would be d capital T over t minus 50. And on the right side, there would just be the constant times d time. Now that they're separated, we can integrate both sides. Oops, that was supposed to be a capital T. Okay, so the integral on the left side is just going to be the natural log. So we'll have the natural log of t minus 50. And on the right side, there would be k times t plus a constant. And I suppose that I could go ahead and get rid of the natural log, so exponentiate both sides. On the left side, they cancel, just leaving t minus 50. And then on the right side, I'm going to rewrite this as e to the c times e to the kt. Because when the exponents are added, that's the same thing as saying e to the c times e to the kt. And I can even add 50 to both sides. Which is basically saying there is the temperature, which is going to be decreasing, but there's always going to be this plus 50 because the room is 50 degrees. Okay, then is there any other information given so that we can plug numbers in and perhaps find out what C is equal to? So go back to the problem and let me clean it up a little bit. And the information is after 2 hours, the temperature is 94 degrees. And I don't see any other new information. So after 2 hours, the temperature is 94 degrees. So 94 degrees is the capital T for temperature. And then time is 2. And then the problem with that is I have both a C and a K to solve for, but I've only got one equation. So I must have missed something. Let me go back and read it again. Oh, I did not use the 98.6. So when the person dies, so that's saying when time equals 0, then the temperature equals 98.6. So there's the second piece of information that I need. So just go back to this equation and say if the temperature is 98.6, then the time is 0. And then we would have this part becomes e to the 0, and that's just a 1. And so we could then solve for, hold on, that's not the pen. So then we could solve for e to the c by leaving it there and just subtract 50 from both sides. And so e to the c would be a 48.6. So I don't really need to solve for c because I can just substitute the e to the c directly right there. So for that equation, we would then have 94 equals, replace e to the c with 48.6, and then there's e to the k times 2 plus 50. And then we're almost done. So subtract 50 from both sides. So right now I'm trying to find out what k equals. So subtract 50 from both sides. And this will be 44 equals 48.6 e to the k times 2. And then just divide both sides by 48.6. And then it's time to use natural log. So I've got a 44 divided by 48.6, and then take natural log of both sides so that these two can cancel. And then go over to the calculator. So 44 divided by 48.6. So what is the natural log of 44 divided by 48.6? And then that's what k times 2 equals, so I'd still need to divide by 2. So k is equal to a negative 0.05. So k is equal to negative 0.05, which means that it's the temperature is dropping at an exponential rate of 5%. Okay, then where was my equation? So my equation was back here. Let me just grab that. And then finally, it's going to look like T equals, and then we need the e to the c, and the e to the c was the 48.6. The e to the c is 48.6. So this would be 48.6, and then e to the negative 0.05t, and then plus the 50.